Welcome to Across the Globe. Today we will learn about vectors in R. In R, vectors are one-dimensional arrays capable of storing numeric, character, or logical data. They serve as fundamental elements in R, widely employed for data manipulation and analysis tasks. Vectors are crafted using the C function. For instance, a numeric vector can be created by typing C1, 2, 3, 4, a character one by using C apple, banana, orange, and a logical vector by entering C true, false, true. These vectors play a crucial role in storing and organizing diverse types of data in R, facilitating various computational operations. In R, vectors are essential data structures for storing multiple values of the same type. They can be created using the C function. For instance, to create a numeric vector with values 1, 2, 3, 4, 5, R numeric vector C1, 2, 3, 4, 5. To create a character vector with elements apple, banana, orange, R character vector C apple, banana, orange. And to create a logical vector with values true, false, true, R logical vector C true, false, true. Varying types of vectors can contain different data types such as numeric, character, logical, etc. For instance, when working with a dataset, a numeric vector might store numerical values like temperatures, a character vector could contain names of products, and a logical vector might hold information on whether a product is in stock or not. In R, vectors allow for accessing individual elements by using square brackets. Notably, indexing in R begins at 1. For instance, numeric vector 3 would output 3, character vector 1 would provide apple, and logical vector 2 would yield false. This method is pivotal for manipulating and extracting specific data points from vector structures accurately and efficiently. In R, you can carry out arithmetic operations on vectors where operations are applied element-wise. For instance, to add two vectors in R, you simply use the plus operator. If you have vectors vector 1 with values 1, 2, 3, and vector 2 with values 4, 5, 6, adding them together will result in a new vector with values 5, 7, 9. This indicates that each element in the resulting vector is the sum of the corresponding elements from the original vectors. Think of vectors in R as a group of soldiers standing in formation, each with a specific position and direction they are facing. Just like how a commander can easily command the soldiers to move in a certain direction or perform a specific action, we can manipulate vectors in R to perform mathematical operations or transformations. If we want to add two vectors together, it's like combining two squads of soldiers to form a larger group, with each soldier maintaining their original position and direction. Writing a program to perform vector operations in R is similar to giving commands to the soldiers, telling them how to move and interact with each other to achieve a specific goal. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. This R code demonstrates the manipulation of vectors using basic arithmetic operations. Two vectors, soldiers 1 and soldiers 2, are created to represent the number of soldiers in two different squads. The addition operation is performed on these vectors, combining the number of soldiers in each squad. The result of combining the soldiers is displayed using print. Scalar multiplication is then performed on soldiers 1 by multiplying it by 2, showcasing how we can easily scale the values in a vector. The result of the scalar multiplication is displayed using print as well. The code proceeds to calculate the dot product of soldiers 1 and soldiers 2 using the sum function. The dot product is a mathematical operation that combines the elements of two vectors to produce a single scalar value. The final result, the dot product of the two squads, is displayed using print. This code example illustrates how vectors in R can be manipulated for various calculations, such as addition, scalar multiplication, and dot product, making it a valuable tool for numerical computations in data analysis, statistics, and other fields. In industrial applications, vectors in R are used extensively for various data manipulation tasks. One such application is in the field of finance. Financial analysts often use vectors to represent stock prices, returns, and other financial metrics. Utilizing vector operations, analysts can calculate portfolio returns, perform risk analysis, and optimize investment strategies. Another real-world example is in the field of genetics and bioinformatics. Researchers use vectors to represent DNA sequences, gene expressions, and protein structures. Vector operations in R enable scientists to compare genetic sequences, analyze gene interactions, and infer biological relationships. Across the globe, professionals in different industries leverage the power of vectors in R to solve complex problems, make data-driven decisions, and gain valuable insights from their data. Keep learning, stay curious, and I'll catch you in the next video.